Hello, good afternoon, everyone. Today we will see the logistic regression in machine learning. Okay, first we will introduce to machine learning. There are the agendas we will see in this machine learning topic. What is the classification? Introduction to logistic regression, linear versus logistic regression, sigmoid functions, mathematical model, cost function, model training, decision boundary. Next one is the type of logistic regression. Then is the model evaluation. Okay, we will see the advantages and limitations also in this topic. Okay, then what is the introductions and what is the logistic regression? Last session we will see the linear regression, correct? Then now we will see the logistic regression is the next one topic of the uh, s- linear regression. Okay, we will see the what is the logistic regression and why we are using this it is. Okay, first of all, there is the introduction of the machine learning. Okay, what is meant by the machine learning and we why we are using the machine learning? Okay, now we will discuss in the machine learning is artificial intelligence topic where the system learn from the data, correct? Okay, there is the we can start with a simple explanation like this. Machine learning is the subfield of artificial intelligence where computers learn patterns from the data instead of the being explicitly programmed for every task. In a traditional programming, developers write the step by step rule of in computer, but in the machine learning, instead of the writing all rules, we give the computer large amount of data and system learn of the patterns on its own. For examples, first is the email spam detection, Netflix recommendations, and all these are the examples of the supervised learning and machine learning. Types of the machine learning. There are the machine learning mainly divided into three types. Measures is the dependency on how the system learns from the data. First is there are the supervised learning, second is the unsupervised learning, and third is reinforcement learning. Each type used to a different kind of problem. First one is the supervised learning. Okay. The supervised learning is the most common type of machine learning. In this approach, the model is trained using label data. This is, means the data is already contains and the model is relation is between the input and output variables. Is a predict the result for the new data. Okay. Example, suppose we want to build a models and we will create the spam emails and spam detections. We will provide a data sets like emails, spams, email not spams after learning for this example of the classify to the emails correctly. Next one is we will see unsupervised learning. What is meant by the unsupervised learning? The data is, does not have labels data. The model tries to find a hidden patterns or structure in the data on its own. Instead of the prediction and output, the system tries to group the organized data. Example, suppose a company has a customer data but does not know customer categories. The algorithm can automatically group customer into segments such as high spenders, medium spenders, and low spenders. These are the commonly used the customer segmentation, market analysis, and pattern discovery. Next one is the reinforcement learning. Reinforcement learning is the type of approach where the model is learned and interacting. Okay, the there is the reinforcement the system takes, and the system takes learn which action provide the best. Okay, there we will see the self-driving cars, learning how to drive, game playing, AI like chairs or Go, robots learning is the task of the reinforcement learning. The goal to the maximum the total rewards over the times. Okay, the simple closing lines for these slides we will overall the machine learning system learn from the data and depending on how data is structured, we will supervise learning, unsupervised learning, and reinforcement learning. We will see it. Okay. And this session, we will mainly focus on the logistic regression, which is the supervised learning and used to classification problem. Okay. What is the classification? We will see first on and then goes on your today's topic is the logistic regression. Okay. First means first introduction of the machine learning, and second is the what is the classification. Okay. Then the classification is the type of the linear regression, correct? Mm. The classification, the type is linear regression, logistic regression. There are the two types of the supervised. First is the classification, second is the regression. Classification is a very common problems in a machine learning. In a simple terms, classification is the process of the prediction and category class for given input. Instead of feeding a number, the models are using the data for group the along the output, usually director category, non a continuous data. Okay, for example, if you give the system informations, then non-spam category we are using the classification. Example of the classifications, let's look at the real world example for understand this better. Email classification. Email is a spam and not spam. Email is a services like Gmail automatically detect a spam emails. The model analyze the features such as the sender informations, keywords in the emails, frequency of the similar messages. Based on this pattern, it classifies the email. The second one is the loan approval prediction. Okay, what is the second example? Loan approval prediction, approved or rejected. Loan is approved or rejected. Bank use the machine learning model to predict where loan is applicable or should be approved. The system consider factors like income, credit card, employment status, past repayment history. Using this input, the model is classified the application into approved or rejection. There is the customer chunks predictions. Okay, what is mean by that? The customer churn or not churn is the companies want to know whether the customer will leave their services. Okay, the machine learning is the analyzes factors like customer uses pattern, subscription history, complaints, and this model predict where the customers likely to churn or stay. Okay, the fourth one is the disease prediction. The disease is a positive or negative in healthcare. The classification models are used. Okay, the classification models we are using in the healthcare productions help to doctor predict the where the patients has disease. Okay, for example, uh, diabetes prediction, and others also. The cancers detect healthcare disease prediction. The model is analyze medical history, lab results, symptoms. Then it classified the case or a positive, negative. Last one line is the logistic regression is mainly used for a classification task. One of the most commonly used algorithm for the classification is the logistic regression. Even through the name of the content, the word is a regression. It is mainly used for the classification task. Logistic regression predict the probability of belonging to particular classes. Okay, for example, probability that an email spam detections, probability that loan will be approved, probability that diseases is present. Based on this probability, the model assign the final labels. Nice. So now that understand the classification is the main algorithms we were using for the data prediction, and the next one we will see their algorithms also. There is the logistic algorithms. The supervised learning use the label data input model output. There are the fourth algorithm we will see. First one is the linear regression, decision tree, logistic regression, and support vector machines. This session we will cover the logistic regression. Okay. Now let's move to the main topic is the logistic regression. Logistic regression is the machine learning algorithms mainly used for the classification problems. In supervised learning, the model learns from a labeled data, meaning that the dataset already contains the correct answer. The goal of the logistic regression to predict which class and data belongs to. Even though the name contains the word regression, logistic regression is actually used for the classification. Okay. The prediction probability also used in the logistic regression. What is meant by the prediction probability and that instance belong to a classes? Instead of the directly predict a class like yes, no, logistic regression first predict the probability then an instance belong to a particular class. This probability value always lies between 0 and 1. You can think of this confidence 0 and 1. For example, 0 means event in very unlucky likely and 1 means the event is very likely. So the model is give us a probability that indicates how likely the events is occur. There are the output range. We will see the regression always lies between 0 and 1. Okay. The example we will see this make is very useful for the problem when we will start estimate like likelihood of the something happens. For example, the probability that email is spam, the probability that loan will be approved, the probability that patient has been diseased. The example, let's look at the simple example. Suppose we build a machine learning model, predict the well patients is particular diseases and not. The probability of the patient is a zero point 0.8. This means is there was the 82% chance the patient has been diseases. In the classification problem, we will use as a threshold value and which is a commonly is a zero point 0.5. Okay. So the rule become if a probability greater than zero point 0.5, the prediction is the positive. If the probability is less than zero point 0.5, the prediction is the negative. Since the 0.82 is a greater than zero point 0.5, the model will classify the patients and as positive. Now the understand the logistic regression is the prediction probability and let's compare the with the linear regression. Okay. Now we will see the next one topic is the why not the linear regression. We will use this same example why we are using the logistic regression. Okay. The linear regression is a continuous value. Before understanding logistic regression deeply, it's important to understand why we cannot use the linear regression for the classification problem. Okay. First, let's quickly start with the linear regression. Thus, linear regression used to predict a continuous value. Okay. For example, the predicting house price, predicting sale revenue, predicting temperature. So, if we input features like house price, locations, number of rooms, and the model might predict the something like house price is the $25,000. They work well because house price can be any real number. The number will linear regression. Now imagine we will try use to linear regression for a classification problem. Prediction whether a patient has a disease. Okay. In a classification, we went to output the represent probability which must always lie between 0 and 1. But the linear regression does not restrict its output range. Okay. Okay. Then next one is the linear regression may produce value like -2, 1.5, but probability must be between 0 and 1 solution. Logistic regression is also used, but there is the one probability we will use that is the 0 and 1. But a linear regression does not restrict its output range. It can produce value like -2, 1.5, 3.2. The value does not make sense as a probability because probability cannot be less than 0 or greater than 1. But probability must be like 0 and 1. The -2 is impossible. 1.5 is also impossible. This is the why linear regression is not suitable for the classification problem. To solve this issue, we use the logistic regression. Logistic regression uses the special functions called as a sigmoid function, and that transform the value between the numbers 0 and then 0 and 1, because of the logistic is lie between 0 and 1. So no matter what the output is, an output will always stay within the valid probability range. Because of the property, logistic regression become perfect for the classification task. So with the key idea here, the logistic regression ensure that the output between 0 and 1, and it achieves that using the special functions, and the special functions is the sigmoid functions. Okay, we will see next one. Our topic is the logistic regression concept, which concept we are using, and what is meant by the sigmoid functions. Okay, will we come on the next topic is the logistic regression concept. Now let's understand how the logistic regressions actually make predictions. Instead of the predicting the final case directly, logistic regressions, instead of the predict the value, instead of the predict the value, we will see compare the linear regression and logistic regression. The computer the linear equations are the calculation of the data, and the model is calculate the linear combination of the input of the data. B1 and B2 are the weight assigned those features. B naught is the bias or intercept term. So initially the essentially the model is multiples each feature by the weight and adds them together. The formula we will use there is the z equals to b naught plus b1 x1 plus b2 x2. Applied the apply the sigmoid functions, output up becomes a probability. So we will convert the value into probability. Apply the sigmoid function to convert the value z into probability. Logistic regression use the special functions called the sigmoid function. The sigmoid function takes any real number as an input and transform it into a value between 0 and 1. After applying the sigmoid function, the output becomes the probability that the instance belong to a particular class. For example, if the output is a 0.8, there is a 80% probability that instance belong to the positive class, and the output is a 0.2, it is 20% probability. There is the sigmoid function we will use for the output become the probability. The components that convert the linear output into probability, they use the sigmoid functions. Okay, and this are the next we will see the functions work like the 0 and 1s, and why we are using this. Okay, the next one our topic is the sigmoid functions, and we will describe it is briefly to understand sigmoid functions. Now let's talk about a very important components logistic regression, which is the sigmoid functions. The sigmoid function used to convert a numerical values into a probabilities. Earlier we will see linear equations give us value z, okay, which can be any number such as a 5.1, 5 minus 5 or even 10, but probability must always 0 and 1. So we need a function that can transform the data, and this data we were using for the correction of values in this range. Okay, this is exactly sigmoid function does. The mathematical formula we are using there is the alpha z equals to 1 by 1 plus e minus z. Z is the value calculated for the linear equations, and e is the mathematical constant, can is the Euler number. Okay, the z is the linear equations and is the value of the Euler number. When to apply this formula Z, the result will always be 0 and 1, which make it predict for representing probabilities. The properties of sigmoid functions, few important properties of the sigmoid function. Output range. The output of the sigmoid functions always lies between 0 and 1. Okay. This means result directly represent a probability. Next one is the S-shaped curve. If we plot the sigmoid function on a graph, it's form S-shaped curve. This curve is a gradually move from 0 and 1 as the input value increases. So very negative values gives output close to 0 and very positive value gives output close to 1. Converts linear output into probability. The most important role of the sigmoid function is that it converts the linear output from the model into probability value. This probability that helps us decide the final classification result. For example, the probability is 0.75 is the positive and 0.30 is negative. Understand the sigmoid function. Sigmoid function convert the linear regression, and there is the use of the output probabilities. The mathematical models we were using this is a logistic regression, and see how its components work together. There is the next one is the logistic regression equation. The logistic regression equation, the logistic regression model equals to Py equals to 1 and 1 upon E minus E by B1x, where is the B naught is the intercept and B1 is the coefficient. There we are using the input features. The output of the class probability is the class of 1. Okay. There is the logistic regression. We will see the formula and we will explain this, the formula concept. Okay. Now let's look. Now let's look the mathematical model behind logistic regression. The formula for the predict the probability that the output belong to the class 1. The B naught is the intercepted of bias term, and it shifts the curve of the left of the right terms. B1 is the coefficient of the weight assigned of the input features X. It shows how strongly the features influence the predictions. X is the input feature of variables. How it works? First, the model is to calculate the linear combination of input and coefficient. Z equals to B1x. Then it applies the sigmoid functions, the part of the fraction and exponent to convert this Z value into probability between 0 and 1. The result equals to Py equals to 1. It is the probability that instance belong the positive class and the class is the 1. Example, for example, Py equals to 1 equals to 0.85. It means the 85% the chance the input belong the class 1. Based on the choose value, usually 0.5